Yeah, as you know, going into this here, this is a presentation that we've been knocking around for about a year or so. It keeps getting improved and updated and that kind of thing. But as Steve indicated, we've been doing this for quite a while. Sorry, everybody, I've got a cold, so it doesn't sound like the real Bob, but believe me, this is the Bob. Um, we've been running this. I've been calling it the FuzionView tour. We've been running around quite a bit in the last, well, not the last month, but a couple months prior to that. Pretty much everywhere up in the upper Midwest to do this presentation. So it's gotten the rounds and it's been tweaked pretty well. Um, I'm going to do this little presentation here. It's about a 20-minute, 25-minute, depending on how much detail I go into. And then at the end of it, I'll jump right into the application as it stands now and kind of give everybody a review where we're at. Um, as Steve indicated there, on some of his sheet, this has been something that's been, kind of cooking along for quite a while. This has always been kind of a pet project for myself. I've always wanted to do this. I always wondered why it had not been done maybe 10, 15 years ago, maybe 20 years ago now that I think about it. But it's always a project that I always wanted to do. And truth be told, the mechanics and the technical side of it is actually the pretty easy part. It's getting agreement from all the different participants that has been kind of the bigger. I don't want to call it a battle, but the bigger um, procedural aspect to building what we're building. So technically, we had things put together fairly quickly, to tell you the truth, in a real proof of concept mode. Everything came together pretty quick. So this is the Minnesota Utilities Mapping Project. Um, I don't like the name that they came up with. This is something that CGA came up with. It's been known as two or three different names, but they came up with this Minnesota UMP, and then they shortened it up to MUMP. I don't know what the actual real name is anymore, but we started out as Minnesota Utilities Mapping, and that's what I've kind of known it as for quite a while now. I'm Bob Basques, and I'm the technical director at Shared Geo, but I'm also running I'm the project manager for the FuzionView engine. Um, the basic tenet of kind of where we're going here, Bart, Steve already talked about Barb and the fact that he kind of glossed over the fact that he's one of the driving forces on this as well. But Steve and Barb got together here early on in our development process, and they've been guiding the um, group along as we've been moving forward on the development of the FuzionView project. Some of the background aspects of this that are interesting to me is that they've gotten a lot of buy-in from the community from different perspectives. So there's like we've got an actual legal group associated with the project. There's of course the development group that I'm kind of running. There's an outreach group. There's a group that's just interested in what goes on out in the field and how they would use the applications, in the field. So there's a bunch of different entities here that are grouped up in different capacities to help us define things as we move forward with the project. We had these long-term outcomes that were expected when we first started. But the gist of it is we're trying to get to the point where we've got all of the underground facilities that we know about are mapped and available to end users when a ticket comes in and goes through the Gopher State One call system. The results being safer excavation, increased efficiency, cost reduction, those kinds of things. Related to the, kind of the efficiency side of it early on when we started putting a lot of this together, it really became apparent that engineering ticket requests, and there are different kinds of requests that go through the Gopher State One call system. One of them is called an engineering request. And just sharing data from the engineering perspective, different entities that are engineering firms, and trying to get the data out of these different data providers or data owners for their feature data sets out in the field. That's always been a painful aspect of doing any kind of new design work out in the public right of way. So the point of just being able to share data at that engineering level popped out of this production of the FuzionView engine early on. That was a key point that everybody kind of noticed came out pretty quickly. And um, the that was something that could be solved very well by the FuzionView engine itself. Um, a summary, a real quick summary of the technology exists. I already talked about that it wasn't a real big technical leap for us to build this. The ticket excavation project area is used to control for selecting the area and viewing of maps. What that really means is the data that the FuzionView engine pulls together from all of these different data providers that are connected to the system. It only grabs the data from each one of those systems within the area of interest for the Gopher State 1 call ticket. So you're looking at the particular map there. That outer dashed black line is the 100-foot buffer off of the black line, which is the actual Gopher State 1 call ticket boundary. We put a 100-foot buffer on there, and that was arrived at by the community. We're just using that as a standard to use as the clipping area for the data that comes into the FuzionView system. When a ticket goes through the system, I'll get into more detail on this. It's actually clipped to that 100-foot buffer before it actually goes into any of the FuzionView data systems on the back end. So the viewing is accessed by users is limited to the one call ticket. The supplemental information only. Must comply with all kind of state one call laws. We're not trying to change any of the existing one call systems. The idea behind the FuzionView engine is this is an augmented data compilation that we can just add on to the existing ticketing systems that are already in place. And then the user and facility operator agreements are being kind of crafted right now while we're getting into this, this candidate version of the FuzionView engine that OCC is starting to put together right now. They're actually starting to build it internally within their systems, and that candidate release will be the first version of that they've done on their own. So they're building that system right now. That's in play right now. They're actually working on that. The pilot system, we've been going at this for quite a while, but the first version of things that we had that kind of worked was back in 2022. We've got this beta version that was recently signed off on by everybody on the OCC side and the Gopher State 1 call. And then, this implementation ready first quarter of 2025, we're right there right now. We're starting to build that and put it together. And then the facility operator controls their data and the access to their data. The way that OCC is implementing it, I don't want to say the control is lost, but the facility operators will have access to their own, the data that how do I say it? I shouldn't say it that way. The facility operators have complete control over what data they're sharing because of the way that the system connects out to their data services. They have control over whether or not those services are available to them or not. Sorry, I got a cough. So I got my cold here caught up with me on my speaking. Sorry. Steve talked about the Common Ground Alliance. Oh, Jesus, is back a couple years now. They did a case study on the Minnesota project when we first got going. And it's a high level kind of view of what we're doing, but it does do a very nice explanation about what the project is all about. And it's like a page and a half, maybe 2 pages. It's online. If you just go to look up MUMP and CGA, it'll come up in the top of the list that comes back to you. I may even have a link down at the end of this presentation, I believe, that I threw in there for that. But it's a really good kind of a summary of where the project got its beginnings and what it's going to solve in the end. And it's still very valid or pertinent, to what we're working on. Oop, too far. Hang on. Collaborations with similar efforts. We did quite a bit of research when we first started the project. We talked to a whole bunch of different groups that were doing similar things or trying to do some kind of combined mapping system. We talked with some DEX as actually been kind of partnering with us as we've been moving forward on a lot of this as well. It sounds like they're probably going to leverage the open source project once it's released. Colorado had a very interesting approach to a lot of the similar kind of work here, but they're Colorado, it was the DOT in Colorado. They were managing things from a project level. We're trying to build things for the whole state of Minnesota. But Colorado was doing some very interesting things with like, requiring a bunch of potholing and stuff ahead of a project versus waiting until you're actually doing the work. Actually going out and starting to do the construction. So they did quite a bit of research, field research before the project went ahead. And that's the way that they're kind of running a lot of their projects now, from what I understand. And that has reduced their hits and accidental strikes quite a bit. We reached out to European Underground, Montana National Underground Asset Register in the UK. So we didn't just kind of, try and develop this within our own little, neighborhood here. There was quite a bit of research that we did early on, with respect to, what's the best way or best approach to move forward. The FuzionView engine itself is going to be an open source set of software APIs. There's some other pieces of the equation here that I'm going to show that we built just to demonstrate the FuzionView functionality. They're not required as displayed, I guess is where I'm going. I'll get into that in a little bit more detail when I get to those. But the point of it is the FuzionView engine is a separate piece of the equation, and then there's a bunch of other things that you can do with that FuzionView engine related to sharing data and how you display it. So the FuzionView down the line, it has been designed. The engine itself has been designed to be able to handle 3D data capture for features out in the field. We're working from the perspective of 2D right now because most everybody has a 2D engine, a mapping engine service that's available right now. Most everybody understands how to manipulate the 2D data, but 3D data is coming on real fast, and the FuzionView engine, there's no limitations in the way that it's been designed that it is going to be shortchanged when it comes to managing 3D data as well. The development plan as we move forward here, we developed this core engine early on. We haven't really done a heck of a lot we've been doing a little bit of tweaking and stuff for the last few months, but the core engine was actually put together fairly quickly. The way that the data is managed behind the scenes is in a very, I don't want to call it a simple schema, but it's very simplified. It's abstracted down to as far down as you probably want to go. And the idea being that the data as it's stored becomes one data set that has the same attributes across the board. We'll get into that in more detail when I show how that works. But we've got some pioneer partners, about 6 or 7 of them right now, that we're working with. So, it could be MnDOT. We got the City of St. Paul. We've got Eden Prairie is coming on. We got more than one from MnDOT, more than one from City of St. Paul, actually. There's a Hutchinson is going to be in the mix. We may get St. Cloud here pretty quickly. Those are the kind of the main players right now that are helping us with figuring out the process and the workflow for connecting up to the different services, and we're actively working on that aspect right now, pulling their services in and getting the connections made. So the idea there is that, we're working on those kinds of things. And then, this view maps and authenticate users, we've got a mechanism to do that, but that's not part of the core FuzionView engine itself. We built that as part of the package just to purely demonstrate the FuzionView engine in a working mode. And then we're at the same time, we're kind of on the backside of the FuzionView engine development. We're just starting up the field markup and the field data collection side of things, which is going to be dovetailing in with the FuzionView engine itself, but it's considered a separate product. And then the important part of the timeline milestone here is the January 2025 piece there, which we're pretty much on track for kind of getting everything rounded out and ready to go. And the beta testing, early on here too, MnDOT and WSB were, some of the forerunners of helping us out, but all of those data providers that are sharing stuff with us have helped us out, measurably with making things work and figuring out the trip hazards that we're running into as we connect up different data services to the FuzionView engine. There's these agreements that are being put into play as well that OCC will be handling once they've got everything running over on their side, for different people being able to see different things. So there's limitations in who can see what, what kind of tickets, those kinds of things, and that's all already in play on the OCC side. They just need to map the data constructs in the FuzionView engine when we collect the information over into their systems, and then that'll all be in play. Last year, while we were putting all of this presentation together, there's just a couple slides here that Terry Holcomb up at the MnDOT put together for us. And what you're looking at here on this screen is basically this is just their underground um, information or what intelligent information systems or intelligent transportation system. I think that's what it is, ITS. So it doesn't include anything else. This is just their ITS system. So all of that stuff that's on the right there as features is all underground. And then, the left there is, the basic map of what you see when you're standing there. They had a big project last year that kind of they hit a lot of stuff. Let's just put it that way. You can see a lot of the broken pipes there that as they were cutting this trench in, they went through quite a few things there while they were working on some things. So these are pictures that, Terry proffered up. But the point of it is that, that they all of this stuff costs everyone time, money, and it impacts everybody. And, the MnDOT customers are all on the multimodal transportation users, but the same impacts are going to happen for everybody. So, there's there's also a higher you can get into the fatal side of things, people dying from certain kinds of hits, but the point of it is that the more that we can reduce, the better everything's going to be for everybody. So the more we can reduce these hits. So I talked about, early on, the whole idea behind the FuzionView engine is to augment the existing process. We're not trying to change anything. Um, Nothing about the current system. All we're going to be doing, a matter of fact, is the way that OCC is going to initially kind of connect things up is they're just going to connect up the output interface that I'll show here in a few seconds from the FuzionView engine over into their systems before they actually get the whole server stack up and running. So the first thing I'm going to show you, this is the piece that they're going to be linking in first, is the ticket viewer. So this is intended for the design engineers, locators, excavators, kind of all three of those different kind of request types. And the ticket viewer basically is going to show all of the information that the FuzionView engine has collected from the different providers. And then it homogenizes all the information into the APWA, the color coding mapping that they used for spraying stuff out in the field. The FuzionView engine uses that APWA classification separation for the cable and conduit, the electric, the sewer, all of those divisions of different feature types. That's what FuzionView is using behind the scenes to segregate and classify things. And then we also added one layer called reference, which is intended as a way for a data provider to actually give us termination points for anything underground where it might pop up out of the ground. So if you wanted to add in as a data provider, if you wanted to add in the locations of all your light standards, for example, you could add those in to the reference layer. The idea being with that is that as you can see all of the mapping information in the interface here, you can use that information to actually snap it into place in the real world mapping scenario like augmented reality, those kinds of things. The ticket viewer is basically pulling the information in from the OCC system. This is a real generalized set of metadata that comes in with the ticket. But the key point that I'm showing with the slide here is that you can pull the information for the features into your application, assuming you have the right privileges. In other words, you've signed the agreements, they have your name written down, all that kind of stuff. But the point of it is that because the features are being pulled in, we can set up the FuzionView engine to actually set up the downloads for the actual features themselves, and you can pull them into your design software of choice, and or even use them out in the field if needed. But the capabilities are there. These are those APWA divisions of information that I was talking about. So you got the cable communications or communications cable conduit, electric, oil, gas, steam, potable water, reclaimed water, that reference layer that I was talking about, sewers and drains, and then we've also got a layer that we added for survey. That would kind of relate to like survey monuments, anything that's kind of on the, liable to be disturbed kind of thing. So there's a separate layer for survey as well. We've got the options for, putting in different kinds of backgrounds. So you can use, regular street maps and aerial photography from wherever you need to. This whole interface here, this ticket viewer, is not required by the FuzionView engine. This is all populated from a API, and I'll get into more detail when I actually jump into the application itself. From day one, as we were building things, we went for a mobile-centric perspective. In other words, everything that we were building, whether or not it was an administrative interface or working with the actual ticket viewer, would be intended to be able to be viewable on a mobile device. So this the whole everything that is output from the FuzionView engine itself can be manipulated and built for a mobile device. These are all examples. Again, the ticket viewer is just our particular take on how you can present the information. There's an API behind the scenes that is actually populating this whole interface. Same deal with the different kinds of maps that you can use and aerial photography as well. So the next section here, now we're talking about the facility operators and how they kind of manage the data that they grant access to. So, as they're sharing their information with the FuzionView engine, they have a mapped version of all of their tickets that have been that have pulled data from their system in the FuzionView engine. So they're going to have their own map interface into that, so they can pick off of this particular map view and get to one of the tickets, assuming that it pulled data from their system. And they'll also have a tabular version of the same thing where they can just pick the link. You can see the one that's highlighted there. There's 23 items that have been pulled. But the idea here is that the data providers themselves have access to this particular data interface. And so everything is kind of pulling together really nice in that fashion so that they've got the two different mechanisms. So I'm picking on MnDOT here. These are a couple layers that they've been set up for. This is the intelligent transportation systems that they've set up for us already. They set up a surface and then a subsurface layer. So there's two different layers. And the way that the FuzionView engine is set up, you can actually combine all of your features into these two separate layers because of the simplification of how the FuzionView engine works and the schema that it's using behind the scenes. So what MnDOT did for these particular layers is they combined all of the information for all of the different feature types that they had and set them up in just these two little service layers. And these are the only two service layers that the FuzionView engine grabs for all of the MnDOT ITS data that is being shared. Each data provider's also got this hamburger menu above, that they can, jump into different kinds of information. They can add new users, add a new data set, those kinds of things. This is the form for adding a new data set. There's not a lot of stuff that you have to worry about as far as, connecting up a new data set or service to the FuzionView engine. And then, they've got different capabilities for managing it after the fact. Don't get lost on the complication here that you see, but what you're looking at here is the mechanism that we're using for mapping the data from the source data provider over into the FuzionView engine itself. So when you look at that big square in the middle, that's an SQL statement. And the idea behind this statement here is how we would map the data. What you see highlighted here in red is basically that's the schema behind the scenes on the FuzionView side. And then the blue parts are what the data looks like over on the source side. And this SQL statement can change depending on what the data is on the source side when you're going back to the data provider end of the equation. So for example, there's that case statement in the middle with the physical status, and this particular service has those four in place: proposed abandon, proposed, and proposed remove. And they're using that as a status ID. And that's what that status ID down on the bottom below the case statement there means on the FuzionView side. So if the physical status is equal and in place, it sets it to 1, which we're using the the numbering system inside of FuzionView to handle that kind of thing. So by using this kind of a select statement process, we can push different things from the source service into the FuzionView engine. And this particular SQL statement is just applied whenever a ticket is pushed through the system. So we've talked about the ticket viewer, and then we talked about the kind of administrative interface that each data provider has. There's also going to be the management from the OCC side. This probably isn't as much of a big deal for everybody here, but the point of it is there, if you look at everything from one further level up, you can see these are all the different data sets and contributors that we're running right now. Some of these are just open data. I can tell you right now that the Washington and St. Louis and Ramsey County, even McLeod County, actually, I think. Those are all open survey data sets that we pulled in. We didn't even go out and ask them, that we just used them for testing. Everything that you see in this right now that I'm showing you, even when I get into the live system, is all of our data providers that have agreed to help us. It's not the permanent setup. That's going to be handled over in the OCC side once they've got the candidate release in place. They'll actually be going through the process of getting everybody that contributes data to sign their agreements and everything. Right now, we're doing this as a kind of a demonstration, and these are the folks that are helping us with that. But the idea there is that from the administrator's perspective, you can jump into any one of the data providers and get to their information and help them if they've got problems or some kind of thing starts to break or something like that. So this slide right here is kind of an overview of how the FuzionView engine works. And I wrestle with whether or not to put this up at the beginning or down at the end like this. And I've done it both ways, and sometimes I've had it on both ends. But I decided to put this one at the end this time. So the point of it here is you get when the ticket request comes in through Gopher State One Call or OCC systems. The information from the OCC system comes over into the goes into the FuzionView system, and with the defining bounding box, in other words, that dark line that I talked about when we were looking at the ticket viewer, and the data request is sent, to the utility GIS databases after that. So first, the FuzionView engine records the ticket, puts all of the information away metadata-wise for the ticket itself. We haven't gone out and grabbed any information yet. We haven't gone out to any of the data providers yet. All that FuzionView is doing in this step 2 is just recording the ticket information. We keep the polygon and all the metadata ticket for analytic purposes. So all of that information and the polygon that the ticket comes in under is kept in the FuzionView engine, and we're maintaining that for future analytics. But when we go to the next step here, this is when FuzionView engine actually goes out and runs those little SQL statements against all of those different services that we were talking about, that with the data providers, and the data provider information comes back in. There's about a 5-minute lag between the time that the FuzionView engine gets the ticket and the time that it can be between 5 and 10 minutes, and it's mostly for load balancing. We don't want to bind up any system. But between the time that the ticket comes in and the time that the data is ready from the requesting database, service connections, can be up to 10 minutes. Usually it's within 3 to 5. Right now, that's the way it's been kind of manifesting itself. So you got this 3 to 5 minute bump there where you got to wait for the data to be available in the ticketing system. But what happens is the data is retrieved from each one of those data providers, and then it's pulled back into the FuzionView engine where it gets transformed. First, the data is put into a generic coordinate system on the FuzionView engine. It's basically UTM, so we're using that as a state coverage for Minnesota. That's kind of the happy medium for a state level layer. And all of the data is transformed into those 7 or 8 APW classifications that we talked about. What kind of data is it? All we want to do is transfer the fact to the requester that there's data available. This is what it is. And then, if there's certain attributes available in the data, like how deep it is or, the status of it, that's relayed as well. And then all of that information is then stored into the FuzionView engine. Remember, it's clipped back to that polygon, that 100-foot extension, and that's it. All of the data that goes into the database in the FuzionView side is clipped back to those edge boundaries, and that's the only stuff that FuzionView stores. It stays in the FuzionView engine as part of the metadata that comes over with the ticket. There's a begin date and an end date. When the end date is reached, the FuzionView engine will expunge the feature data. So all of the feature data will go away at the end of the ticket's life. Once the information has all been managed and transformed, then the FuzionView engine will send the data link back and let it be known that the data is available to whoever requested it. So back to the Gopher State One Call system, the OCC systems, or or the engineering team that requested it, or the locate team, or the excavation team. As I've been saying and touching on here and there are these agreements that are being put together to view the data, who gets to see what, all that kind of stuff. That's all being managed outside of the development of the project. We've got mechanisms in place that they can use for in the data organization of how they can map who's logged in and let them see different things on the from the ticket management side. So that's all been kind of built and put into place with examples from the beta side of or the beta versions of things that we put together. Okay, that's the end of the presentation. Before I jump into any kind of an application view, do we have any questions?
Good afternoon, Bob. This is Tim Lesh. Can you hear me okay?
Yep, sorry, go ahead.
Okay. Say, how are you doing or dealing with private utility companies? Have you gotten any interest or volunteers or anything to submit data?
Steve, do you want to jump in and give them the judicious answer, or do you want me to answer them?
Hey, good afternoon, Tim. The answer to that is that we are going to proceed. The development plan is to proceed very slowly through the year 2025. There is extensive outreach material that's being developed, and we're waiting for, if you will, a final sign off from Kelly on what those outreach materials are going to look like. We're hopeful that the PHMSA effort will be supportive, and we've tried to take the tack of demonstrating, just as to kind of maybe put your head around this. We believe the potential savings in the state of Minnesota are going to run into the hundreds of millions of dollars. So we believe that it would be very difficult for the utility industry to push back once those sorts of elements are dealt with on the outreach. So we're using municipal organizations initially to try to make sure we get our act straight before approaching Xcel Energy and CenterPoint and so on. Is that helpful?
Well, I guess it's descriptive. What, I'm doing some work with the Minnesota Department of Natural Resources and Parks and Trails, and we are inventorying the utility infrastructure at state parks using high accuracy GPSs.
Right.
And we have lots of providers across the state at the various state parks. And some of them, my experience has been really varied. Some of them, you send a request off to them and a technician gets a hold of you in a day and sends you the information. Others don't ever respond. Some of them have responded with non-disclosure agreements.
Right.
And so that's been fairly problematic for us because the data in our system is classified as public. And so if there is a data request for that information, we have to provide it. So the DNR is just not prepared to sign a non-disclosure agreement with these utility companies. And so we don't get their data.
Yeah. And this is what Bob's been talking about with there's a couple of lawyers in Chicago that are working on I just had a meeting last week on refining the language to be able to support this process. And so part of what has been done here, we knew that would be an issue out of the gate. And so part of the thinking was, first of all, we only clip to the dig site, which limits the amount of data that we're going to request. And secondarily, that there is no retention of data except for the life of the ticket. And if you wander out to a dig site, you can just as well get the information by looking at where the flags are on the ground if that's what you're concerned about. There's far more elements along this, but um, again, part of the reason it's taken so long to get to where we are, and as Bob's addressed, the technical piece is not the difficult part. It's figuring out the administrative and procedural pieces that need to be put in place to be able to support a project like this.
Yeah.
So, whether or not this is going to be the panacea, who knows? We're yet to find out, but we're doing everything we can as meticulously as we can so that when the approach is made to there are 20 utilities in the state of Minnesota which control 80% of the infrastructure. So we're working as hard as we can to make sure our ducks are going to be in a row when those discussions begin.
So is this where? So is this? I'm just trying to frame my question here a little bit. Have you ever had uh, data classification done on this? Is this going to be considered public data, private data? Um, I'm speaking from within the governmental system. We always had to categorize or classify our system based on the Minnesota Data Practices
Yeah.
Act.
So Gopher State One Call, if you're not aware of it, is a self-standing nonprofit. So there can, whether or not there's some level of overreach into that circumstance, I'm not aware of it. The other thing is that there's a wide swath of laws concerning what can and cannot be shared for, shouldn't say laws, I should say policies about what it can not be shared. And again, we've done our very best to make sure we're inside the guardrails on that. So I would have to believe that if nothing else, the way the legal agreements will end up will mitigate the potential that anybody's going to come along with a Freedom of Information Act and ask for data from the system. There's a firm in California right now which called GeoGrid, I believe is the correct name for it. And they're using Freedom of Information in the state of California to to acquire data within the Bay Area system, and there's lots of angry people about it because they're just dumping it into one big database that they're going to use for commercial purposes. So again, I apologize that I'm kind of rambling here, but there are a ton of nuanceical things that involve the protection of data, how licensing is written, what the potential is to get sued, so on and so on and so on.
Just a little bit of a follow-up too there is, you know, Tim, the idea that we've had from day one is let's expose the capabilities and then figure out what limitations we need to put on those capabilities after the fact. So that's been kind of the way that we've been focusing on development. There's obvious things that we just never even built, but I mean, the point of it is that we think that we're at a good spot where we can filter the data output accordingly for the utilities to have a very minimal kind of stake in the process, I guess you'd say. From just purely from the engineering side of it, you can have an engineering company go in and sign all the agreements that they need to, and not have to worry so much about. They have to give them the data anyway. I mean, they're doing it already. It's just a long drawn out process to do it. So, we're trying to speed that whole process up with what we're doing. Megan?
Yeah, thank you. And I appreciate this conversation. Good question, Tim. And it makes me have some ideas about the potential answer to my question. But I see like this application serves a really big need across the community, but has a need been identified to facilitate underground utility data access for users that aren't pursuing excavation projects? I'm thinking of emergency managers that might be putting up an incident command unit, other government agencies, things like that. And then my second question to that is, does the EPC plan to pursue a workflow for supporting those other needs?
Steve, I'm going to throw that one over to you. I mean, I can obviously go after it if you want me to.
Yeah. So, what would be helpful, I think, for the conversation is to understand that we are still on the the build part. Let me back up and say it this way. There are two central components to this project. One is the technical build, and the second one is the like where both you and Tim are going. The procedural, how do you get people to cooperate? What are the motivations that are available? What groups, like Minnesota Emergency Management Group, are out there that potentially could support this project as it matures. There's a very, as I noted in my note, there's a very real need if a fire department is responding to a place where there's been a gas break for them to be able to know what else is underground around where we're messing around. So we, over the next 2 to 3 months, are going to be coming up with an approaches that deal with further funding of the program, what kind of marketing do we need, and what sort of allies are out there that potentially can be tapped into to support this effort going forward. And ultimately, Megan, I think maybe what you're asking is I vision that as this transition happens where it goes over to OCC, there will become a more and more diminished need for EPC participation in this, that it will evolve into its own sort of thing, maybe even on a national level. That's where I potentially see it going. Is that helpful?
Thank you.
Yeah, I got a little bit of a follow-up there too. And Steve's going to roll his eyes, and so are my developers that are online here as well. But from very early on, we identified the idea that the FuzionView engine could be used in other ways besides underground utilities. The back end schema that's inside of there right now is purposely keyed to underground utilities, but it could be accessing in a whole nother database that's related to parcels, for example, or hazardous materials for response, or we're focused on right now the underground utility stuff. That's who's paying the bills. So that's our main focus. But the FuzionView engine could be used for all different kinds of business types and different kinds of ways of pulling data, disparate data together into some kind of a generic system where you're always going back to the source and getting the most freshened up data that you can and pull it back into that seamless data set. I would imagine in a lot of those other business aspects too, they're going to be a little bit simpler and how do I say it, lower level security risks. I guess you could say there's going to be more of those out there. There's probably other ones that are just as squeamish as underground utilities as well. But the point I'm making is that the FuzionView engine was not put together with the sole idea that it could only handle underground utilities. We're just focused on that right now because that's who's paying the bills.
Yeah, thank you.
Any other questions? All right. So the area on the map here, this is a city of Glencoe. This is where a lot of our original beta kind of test data was compiled. So we got a little bit of data that's available in this particular area. I can turn on the electric layer, for example, and you can see that there's this is a live system, by the way. So the tickets that are shown on here are tickets that are actually in the Gopher State One Call system. And I can turn on different layers inside of here, and you can see each one of them is actually popping up inside of the particular ticket areas. And we can go in here and actually identify a particular ticket and get to the ticket viewer, that we're actually looking at. You can see here's the information that pops up for the particular features in this particular ticket. And then you can pop up any of the attribute lists. You can see that the data that is being popped up is all fairly, how do I say this? Innocuous, in that it's trying to do is say, okay, this is an electric line, this is who owns it, that kind of thing, when it was updated last based on their participation, all that kind of stuff, nearby features, all that. But the point that I'm making here is that the data has all been kind of been transformed and pulled into a common projection. And the way that the data is shipped back out, it doesn't matter where it came from or who contributed the data. Everything has been pulled back into and published through the FuzionView engine in this common kind of data set. And then you can see here that you can pull the points down, in different formats, those kinds of things, for use inside of your engineering software of choice. And then, the basic metadata is available there. You can see how many features got pulled down. So if there's a number over here on the right, that's how many features of that particular type got pulled into the interface. And then I mentioned, back here when we first started on in the presentation, the fact that the API is being used to populate this interface. It's the same. You notice when I did my query here that two links came up. The second link here is our most recent version of the map system, but the first link, this is the same ticket. The same API behind the scenes is feeding this interface as well. So what I'm trying to demonstrate here is that you have the option of using that API, or whoever's going to be building against this has the option of using the API to build a system in any way that they want to appear. So you can, individually, in this particular one, show the data, from different perspectives in each one of these different layers that are pulled in. And then, this was just our very early attempt at kind of collating the data that was coming in, trying to do our tabulations here on the left side, what is going to happen, just the different kinds of things that you could do with the different tools that are available. And then we also have a ticket link back into the existing GSOC system to get to the original ticket. But the point I'm making here is that the data that's coming from those APIs is used to make both of these interfaces. The same API stream was used to make both of these presentations. So that's an interesting fact of the way that the FuzionView engine has been put together. So I'm going to jump out here and zoom out a little bit further. And we're going to jump over into the city of St. Paul. We've just recently added the streetlight points for the city of St. Paul into the interface. And so I can show remember, all of these tickets that I'm showing you, these are all live tickets. So we can go in and actually look at the data that's, I got two tickets here that are stacked on top of each other, but I can jump into this particular ticket and you can see all the information. So these red dots are all of the electric stand or posts, basically, for lighting in the city of St. Paul. So these were just added and they're available for the whole city. So we can pull in any of the tickets that have information in the city now have that. This data here is MnDOT data coming from their ITS, intelligent transportation systems that I talked about earlier. And the reason that you've got some of these pink points on the outside here, these are survey data. And the reason that they're outside beyond the cutoff line, that 100-foot buffer, is because they're actually cached locally on the FuzionView side. So they're open data. We were able to just pull them in, and we have a cache of them in the FuzionView service locally. It's basically just to demonstrate that we don't need to necessarily have these connections in place. If somebody wanted to hand the data over to, en masse to the FuzionView system, the capabilities is available to do that as well. one last thing that I can jump into here, and I'm almost done, would be this admin interface. So this is the admin interface that I showed you from um, the operator side. So this would be the OCC view. But you can also jump in, here's the data sets that are shared from the city of St. Paul, for example. And remember, I was talking about the idea that you could go in there, see how much simplified this SQL statement is on theirs. They actually have all the information kind of available already. There's these optional fields right here. They basically have said that we're not going to populate them at all. So size, depth, and accuracy are not being populated in this particular data set. And then you can go in and actually edit and change around what needs to be done on the different layers. So you can change the source data set and where it's coming from. This particular one is coming from an ArcGIS service. And then the commensurate SQL statement is in place. But some of them can be fairly, well, that one's not a good complicated one. Let me go to MnDOT. They got a nice one there. Let's see. Got to go back further. So if we go to MnDOT and subsurface, there's that case statement I was talking about. So this SQL statement basically works across the board for all the different kinds of data sets. And then this is that hamburger menu that I was talking about. There are different options for different things that you can do inside of this. You can jump over into the documentation, log out, all that kind of stuff. So there's plenty of room here to enhance the system over time. Right now, this is the engine proper that I've shown you everybody. But there's all kinds of potential here for that field data collection side of the equation that we're working on now. So I believe that's the end that I've got. I'll throw this is that case study link that I was talking about on the end, that you can go and look up that 2.5 pager, I think, from CGA. I'm done, unless there's any more questions after I run through the interface there.
Bob, you have a question from?
Yep, go ahead, Ken.
I came on board this a little bit late and I have to leave, so I can't follow through too much. I do search and rescue coordination operations. So one of the things that I think I caught, but I just want to confirm it, is with this data that you're looking at being able to present, how can this be exported? Because having Tim on this call, also, I've known Tim for many, many years. He was instrumental in providing us data resources for search and rescue applications for many, many years. And he's very right. There's a lot of things in state parks, having worked in state parks, that I know utility-wise are very important for search. And having just dealt 2 years on a particular search in a Minnesota state park, there are a ton of historical data references to utilities running through that park that positively or negatively affected our search. We would want to know what those utilities or whatever data can be pulled out of this, be able to export it and pull it into our mapping program.
Yeah, so our focus right now has been to collect feature data from services that are already available. The FuzionView engine, though, is designed with the idea that if you're a data owner and only have a mechanism to basically scan a old plan or something and contribute that out as your method for sharing information, the FuzionView engine can handle that as well. We haven't gotten into any data providers that do that right now, but the FuzionView engine can handle it. But if you do have a service available, maybe you do have a FuzionView, or if you do have a service available, we can pull the information into the FuzionView engine, and then it can be output.
Yeah, the one you have selected there is the one that we would be able to pull into the package that we use.
Yep.
Which is CalTopo, or otherwise known as SARTopo, depending on the application that
yeah, there are other formats here.
For it.
We just pick these ones to start from. GeoPackage is probably our preferred one. It's kind of like the catch-all. It makes the most sense for not having any errors, but
okay.
So
That's what I was looking for.
So Ken, I'd like to add to the discussion that the reality is that the emergency services sector will need to sign documentation just like others. And I think what may be glossed over is then Bob showing the download capability. That piece is currently specific only to design engineers. So if you're in the system as a excavator or surveyor or whatever, you're not going to have that capability. That's the way the policy is evolving as we sit.
Well, and I would presume in our particular
Policy,
case, we would make the request through the agency with jurisdiction. So in my particular case, it would have either come through Dakota County or it would have come through Egan Police Department.
policy aside, implementation detail. Those downloads and the actual map display are all over WFS. So potentially, and I don't want to get into, I have no idea what the policy gotchas would be here. You could pull a WFS link into an external app per ticket. So each ticket has a WFS associated with it.
We've gone to, how do I say it? I don't want great lengths, but we've gone to lengths to make it easy mechanically to make this all work. It's actually going to be up to other people procedurally and I don't want to say it legislatively to decide who gets to see what where.
With it, that's also where I'm a little hesitant on the just scan things, because this is very WFS based, which is features.
Yeah, we have not gone into any great extent to handing documents out, but we do realize that there are probably going to be data providers that don't have the wherewithal to set up a survey, or not a survey, a GIS system, and be able to distribute their data that way, and they're just using old records. We know that they exist. So
Do we want to talk about the potential for like attachment documents and stuff that might go with things?
well, we're getting into that a little bit with the field data collection, and I think a lot of that kind of aspect mechanically will be fleshed out with that. How we apply it in the future might be a little rougher, but we've been talking about this from the very beginning about how we would handle these kinds of things. So that answer your question, Ken?
Well, I know this is still in the beginning phases, but I'm just trying to digest what might become available. How somebody like me gets access to it is just, that's going to be another question down the road. I don't anticipate being able to just have access to this in this ticket system from my particular perspective. But like I said, we would end up going through the agency of jurisdiction for our cases. But I can definitely see how, especially in this last search, it is probably the second most complicated search I've ever done, and I've been doing this for 37 years. And having had access in an easy form for even just determining water runoff drains throughout the city of Egan as it relates to Fort Snelling State Park, that was a huge jump in being able to understand how contaminated chemicals could be distributing into our search area. And that's something that I don't anticipate being able to click on something and get that within 24 hours. But if I have to go through the agency of jurisdiction and this information is available and we can pull it into a format that we can get into our search data mapping, that would be way positive.
Yeah, Steve's statement is correct. We're right now, and mostly the reason that it's available from the engineering perspective is they already had an engineering request type inside of the OCC system for the one call system. That's kind of why that exists already. But that's what we've been concentrating on and focused on. A lot of these capabilities that we've been adding with the FuzionView engine are all new. So, from the perspective of them as an operator of the underground utilities project, all of that stuff is true that Steve said. That doesn't mean that there's not a method that you could push forward to make this data available in some other form. But, we'd have to figure out mechanically it's doable. If you get the wherewithal of everybody else to participate.
Well, I'll be watching. Thank you.
So, Bob, you got a question from Mitch. What happens when a WFS is not responding?
Is you got a for example?
This is why we're caching. This is why we're
Yeah.
caching.
I was just thinking you're drawing data from multiple web feature services. So how does the end user know that any given feature service is not drawing or not available?
So, I mean, click on the info thing, I guess, Bob. It keeps track. So it caches the request or the responses from the WFS. If the WFS does not return successful, it has a retry policy that kind of ramps down over time, so it doesn't just continue to hit things super hard. But the report out of this can tell which services have been queried, which services have responded successfully, and which services have not responded successfully.
That answer your question, Mitch?
Yeah. So the no
Yeah.
data means for example, oil, gas,
No data
and
is no.
steam.
Yeah, no
Okay.
data means that there was no
Yeah,
data of
and I
that
think
type. Yep.
no data here could mean, and actually we might need to look at this. But no data either means that nothing has been there yet, or that there's actually nothing there.
Right.
I think either
And
of those could be true at the moment.
And not responding would be a different error message or a different message to the user that the electric service is down, so we don't have any information there.
Well, there could be many electric services. And actually this
right.
is looking like it's been simplified since the last time I've seen it, and I'm a little worried that it in the simplification has lost some important context.
All right. Thanks. Sorry to bring us into the weeds.
Everything's available inside of the pop-ups about who owns what. So even though the electrics are all combined based on, depending on who the data provider is, the pop-ups here will tell you who actually owns a particular feature.
Well, yeah, but it doesn't tell you who didn't respond. Where'd the thing go that could tell you who didn't respond? I think somebody put that on a list. We need to get back to that.
Bob, you're on mute.
Yeah, we got the idea right now is that we're just not presenting the information if we didn't get it. So as far as we can't really, we don't want how do I want to say this? The FuzionView engine isn't really in the data provider validation mode of kind of, that's not what it was intended for. It was purely just share data where it was available. As far as going out and requesting something and we don't get anything, that is a different thing. We have to kind of handle that. But if we're not requesting it, then we're not displaying it.
Well, and behind the scenes, it is distinguishing between I made a successful request that returns 0 features from I haven't made a request from I made a request and I got an error.
It's actually a good thing that
right now.
I am gonna make a note of it. So we are going to discuss it further. So good one, Mitch. Any other questions? There's one from Megan again.
Oh no, I was just saying I liked the conversation we're going.
Oh, okay. That's fine.
Okie doke.
Thanks, everybody.
Thanks, Bob.